Hey, hello everyone. Welcome back. Well, I'm starting this series, AKS hands-on series, where I'm trying to cover as much as AK as possible with the help of labs. There is no theory or lab, but we'll be talking about all the features and everything while performing the labs. So this is the very first video in the series where we'll be creating the Azure Kubernetes services with the help of Azure Portal so that we can go through each and every options and try to understand each and every option. This series will end with the architectural concepts of Kubernetes at the end. So stay tuned and do follow and keep learning. Let's get started. So in Azure portal, I'm going to click on Kubernetes services. All you need to do if you're doing this through portal is click on add. Once we hit the add, it will open the wizard. As always, we need resource group for place in the resources. This time it's Kubernetes is our resource. I'm going to give the name as a demo AKS. Click OK. This is the name of my resource group, or I think I should give it like AKSRG, and demo AKS. I'm going to give the name of my Kubernetes cluster, as you see the cluster name. So I'm going to give it demo AKS. Now, I'm in UK West, as you can see, and the availability zones are grayed out. That simply means AKS is zone aware. We can use the zone options for the high availability. And if you guys following my videos, we have already covered a lot regarding availability and availability zones. So no need to get into depth of the availability zones and high availability. Just try to understand this availability zone option is not available in all the regions. If I change the region, there must be zones that I can select. And just to be sure, I'm going to choose East US because East US is the very rich region as per Azure, right? Now you can see I can choose the zones, but it doesn't matter because it's a demo and we do not need a lot many nodes running in a different zones. So let it be East US, that's fine with me. Zones is okay with us. This is the version of the Kubernetes that you want to choose. You can choose. I'm going with the default for my demo purposes. You can even select the zones, or you can select only 2 zones. It depends as per the availability that you're planning. Now we have the option of node pool. Node pool is nothing. It's just the pool of similar set of VMs or similar SKUs of VMs to support applications that have different compute or storage demands. You can create additional user node pools. I'll show you in the next pane because it says next node pool where we can explain it a little bit. For example, if I select one here for the demo, and this is the SKU size, this is the size of the VM that this primary node pool is going to use. So if I hit node pool, you can see this is the node size that it was showing before, and this is the OS type. Now I can hit add node pool and create another pool of the nodes as per the need of my application. Maybe we need a memory optimized SKUs or compute optimized SKUs. So we can create another pool for that. Now we got 2 kind of modes here, user mode or system mode. So you can see here, system node pools serve the primary purpose of hosting critical system pods such as code, DNS, and user node pools serve the primary purpose of hosting your application pods. However, application pods can be scheduled on the system node pools if you wish to only have one pool in your AKS cluster. So there are like 2 different modes for the node pool. If you're using 2 different pool, if you're using a single pool, you can have both mode on a single one. What I meant is application pods can be scheduled on the system node. Okay. Now you can also choose the OS type for your additional node pool that you want, and here is the size that you can choose. So this is what the node pool is. Absolute basic idea you would definitely have now. Now we have another thing, virtual nodes, right? You can see I can click here and make it a virtual node, enable the virtual node for this. Now you must be wondering what is virtual node. So let me tell you a little bit about the virtual node. With virtual nodes, you have quick provisioning of pods. Means, let's suppose your nodes are done. There is no space to give power or to run pods, and to do that you need to spin up another node and then spin up the pods in it. But what you can do, you can enable the virtual nodes. It will quickly provision the pods without running the nodes, and you only have to pay per second for their execution time for the pods, right? And you don't need to wait for Kubernetes cluster autoscaler to deploy VM compute nodes to run the additional pods. Virtual nodes are only supported with Linux pods and nodes as of now. So basically it is backed by ACIs. So virtual node is based on virtual kubelet. Virtual kubelet is an open source Kubernetes kubelet implementation to hook up Kubernetes to other APIs. And virtual nodes enable network communication between pods that run in ACI and the AKS cluster. So it is backed by ACI. Now this setting we talked about, node pool we talked about. Now we have the nodes that this worker nodes are backed by VMSs. So we'll see once the cluster will be created. We'll go ahead and see it will also create a additional resource group, the one that we have created, and there would be another additional resource group would be created by the Kubernetes, where it would have all the supporting services. So let's click on the authentication. Now we have authentication method like service principal and managed identities. These are required because Kubernetes needs to manage the Azure resources, as it has mentioned already here. So Kubernetes needs the identities and some permissions. Now, Kubernetes authentication and authorization. We have RBAC and AKS managed Active Directory that simply help you manage securely, or you can authenticate, authorize, secure, and control access to Kubernetes cluster in a variety of ways using Kubernetes RBAC. You can grant users, group, and service account access. With AKS, you can further enhance the security and permission structure by enabling the Active Directory centralized management of the identities. It would be the role binding to the AKS cluster that we will explore. Or if you have seen the previous playlist of AKS, you must be aware of all those cluster role and role bindings. So this will help you to centralize management and secure and applying RBAC, Kubernetes RBAC, and Active Directory as well. Now, just like any other node or any other virtual machine in Azure, there is an encryption, there is a default encryption, and you can also do as your own managed key, right? Now let's go ahead and click on networking. Now, if you see the networking, there is two ways. There are two different ways of networking, CNI and KubeNet. KubeNet is the default network configuration. And we also call it basic. Azure CNI is the advanced one. This AKS cluster use KubeNet, and Azure Virtual Network and Subnet are created for you. What I'm trying to say here, the KubeNet and Azure CNI, they are two different network configuration. In KubeNet, the pods will not have the IP address from the Azure Virtual Network, but in Azure CNI, they will. When you choose KubeNet and Azure Virtual Network and subnet are created for you. With KubeNet, nodes get an IP address from the Azure Virtual Network subnet. Pods receive an IP address from a logical different address space to the Azure Virtual Network subnet of the nodes. And NADing is then configured so that the pods can reach resources on the Azure Virtual Network. The source IP address of the traffic is netted to the node's primary IP address. This approach greatly reduces the number of IP addresses that you need to reserve in your network space for pods to use, right? Now, if you choose Azure CNI, there's a lot more settings you need to configure. Because Azure CNI is the advanced networking, they call it advanced networking, Kubernetes networking, where every pod gets an IP address from the subnet and can be accessed directly. Yes, you're hearing me correctly, can be accessed directly. These IP addresses must be unique across your network space and must be planned in advance. Let me come back to the can be accessed directly, but not from on-premises, only from the Azure. Okay. Each node has a configuration parameter for the maximum number of pods that it supports. The equivalent number of IP addresses per node are then reserved upfront for the nodes. This approach requires more planning and often leads to IP address exhaustion or the need to rebuild cluster in large subnet as your application demands grow. So a lot of planning is needed for Azure CNI. It has other benefits. You can use the Windows container with this, and no need to work on the routing, because in KubeNet pods, when pods need to talk to the Azure resources, there needs to be route defined, and no need to worry about the routing in Azure CNI because they're getting the IP address from the Azure Virtual Network. So for now, we are going with the default KubeNet, and they have few prerequisites. The virtual network for the AKS cluster must allow outbound internet connectivity, and that's why there is a load balancer here. This is a standard load balancer, and it will provide the outbound internet connectivity. We don't create more than one AKS cluster in the same subnet, right? This is the prereq. AKS cluster cannot use 169.254.0.0/16, 172.30.0.0/16, 172.31.0.0/16. So if I could just write down here, that would be really helpful. So there are few IP address ranges that KubeNet, if you're using KubeNet, cannot be used. These four ranges for the Kubernetes service address range, or pod address range, or cluster virtual network address range. We can't use these four CIDR ranges. The cluster identity used by AKS cluster must have at least network contributor role on the subnet within your virtual network. Okay, so this is some basic about the networking. So this is the very first video in the lab. Just wanted to, if you have seen my previous video, just want to re-jog your memory, refresh your memory. If you are coming first time, this is the very first video. So even though this will helpful, like what these configuration are, but this is absolutely basic. We might dig in deeper in the later videos. So for now, this is more than enough, I think. So let's go and choose the KubeNet, as I said earlier. Now, there is this traffic routing. There's a load balancers will also get created as a standard. This will provide the outbound connection to the cluster node inside the AKS virtual network. right? It achieves this objective by translating the node private IP address to a public IP address that is a part of outbound pool. Okay, so this will take care of the internet part that we are talking about. And this will also help to provide access to the applications through Kubernetes services of type load balancers. Okay, now there is this HTTP routing. We can enable this. This is if you enable this, this is usually we use for development purposes or testing purposes, not for the production, because HTTP application routing add-on is designed to let you quickly create an ingress controller and access your applications from outside. This add-on is not currently designed for use in production environment and is not recommended for production use. For production use, you should have HTTPS TLS ingress controller. Okay. Now we have enabled private cluster. That simply means, as the name says, no public access. To secure access to the publicly accessible AKS control plane, you can enable and use authorized IP ranges. The authorized IP ranges only allow defined IP address ranges to communicate with the API server. Okay. So you can enable, by checking this box, you can enable it. And here you can set the authorized IP ranges, which can talk to the API and do the, as per the permissions, as per the authorization, can perform the operations. Otherwise, all other IP addresses would be blocked. Now we do have network policy here. They're like none, Calico, and Azure. It is usually when we run modern microservices based applications in Kubernetes, we often want to control which components can communicate with each other. The principle of least privilege should be applied to how traffic can flow between pods in an AKS cluster. Let's say you likely want to block traffic directly to backend application. The network policy feature in Kubernetes lets you define rules for ingress and egress traffic between pods in a cluster. So it's a wonderful feature to control the traffic between the pods. Right now, if I click integration, here we have multiple other services that we can integrate with the Kubernetes. For example, you need not to create another registry like Docker Hub for the images. You can utilize the ACR, which is Azure's image registry, Azure Container Registry. We can enable the monitoring, Azure monitoring for Kubernetes. We can also enable the Azure policies for the Kubernetes. Now we are enabling right now for this cluster, and once it is created, we'll see. It will create a default workspace where it will send all the telemetry, all the data. Now we can give the tag, or let's review and create. Now it says validation failed because we might have missed something here, because we don't want it, we want the public, so it's fine. Let me create. So you see, if we click on the set IP address, we need to provide the IP address. Only those IP address would be able to access the API of the Kubernetes. If you have been with me, if you've seen my videos, you have seen a lot of past services have same kind of arrangement, like storage account has that firewall option where you can stop or block all the accesses. You can only give access to certain client IP addresses or the virtual network. Same thing is there in the Azure SQL. So it is more or less same kind of arrangement. Now it would take some time and we would have an up and running cluster. Okay. So I just wanted to say, as soon as the cluster is up, don't want it a huge video. It has already been a little long because we started talking a lot about the features that we were coming through. Now, as soon as this is done, I'm going to show you a different resource group, which is creating all the resources which are created along with to support this Kubernetes cluster. And we'll end this video afterwards, and we'll meet in another one where we can access. We'll see how can we access this cluster and perform our tasks. All right, so deployment is completed. Let me go to resource. You can see the Kubernetes resource is created. This is our AKS resource group. If I'll click here, I'll only find the demo AKS, the Kubernetes service. But if you remember, it was when we were creating Kubernetes, it was asking a lot more information. So where are those resources? All those supporting resources are in a different resource group. If I click here, go to resource group, they would be with the suffix MC, AKS RT demo, AKS East US. If I click here, many resources been created. Let me show you. You see, this is the managed identity so that AKS can manage the resources on the Azure if it needs, right? Load balancer that I was talking about. Let me open it in a new tab so that I will show you. This is not doing as such a load balancing as of now because it's a, there is this outbound rule, right? This is what we talked about. Let me come here and identity for the pool. This network been created by KubeNet network configuration that we chose. There is this VMSS created where our single VM is running, and there is this route table created for the pods inside it, I guess. We'll see. There is one NSU also created. Let me click here on the Kubernetes. We talked about this load balancer. Now, what it is, this is scale set. You can see this is the SKU that we chose for the node pool, and this is our scale set. And if I click on the instance, this is the instance running 0.4, right? If I click here, this is the route table. We also need to check the virtual network. I forgot to click there. There is this virtual network also got created. If I click here, this virtual network is created by when we select the kubenet configuration, and you can see this is /8, and this is the subnet for the AKS cluster. The AKS cluster is running on this subnet /16. And if you see the route table, if you click on route, this is the destination IP address. If anybody, or anybody, but anyone on this subnet wants to talk to any of the IPs from this, it will go through the, this is the IP address of the node, right? It will go through the node. So these are the resources created. And if I go to the load balancer, just checking, under the backend pool, they must be the worker node 04. So yeah, I hope this would be helpful. If you have any questions, concerns, comments, please put down in the comment section. And thank you for watching. We'll start digging a little more in the upcoming videos. Take care. Bye-bye.